All right, Cat in a Hottin Roof is ascending in a helicopter at a rate of 13.3 meters per second at an elevation of 47 meters. She drops a bagel out the window of the copter. What time does a bagel take to reach the ground? What is the velocity of impact? How high is the helicopter when the bagel hits the ground? All these things. Let's do time and velocity of impact, shall we? We'll see. The pen might slow down to the point where we're not doing anything meaningful. Okay, so here's the helicopter. The key here is to draw a good helicopter, right? There it is, right? Oh, we got to do the blades. Oh no. Okay, sorry about the helicopter there, right? The key here, though, is that this when she drops the bagel out the window, right? The bagel's not just going to go straight down because she's dropping it from a window that's moving this at this speed upwards. The bagel's going to go up, right? And then the bagel is going to go down, right? Hit the ground. Okay, so she drops it out the window. It's going to go up. It's going to go down. It's going to spend more time going down than it does going up. So we can't really use any symmetry stuff, right? So let's do from the copter to the ground. Okay, and this, by the way, this elevation here is 47 meters. So that's to this elevation right here. Okay, so if I suvat that, right, A is negative 9.81. That's easy. It's going to accelerate down as it moves up, accelerate down as it goes down. It's always accelerating down. We know that if it starts here and ends there, the net displacement, right, is down 47 meters. And this catches people. They think that maybe they should put the distance in, and then how do you calculate that, right? No. S is not distance. The distance here traveled will be more than 47 meters. The net change in position is 47 down. So that's why we say negative 47. And then we know the initial velocity. Okay, so our initial velocity is positive 13.3. Okay, and now we want to find the final velocity, right? Let's find that first. Okay, and then I'm going to find the time. Okay, so I'm going to use no t to find v. So let's just do this. Okay, so the absolute value of v is the square root of 13.3 squared plus 2 times, negative 9.81 times negative 47. And of course, what's going on here in basic mathematics is that this negative times a negative makes that term positive. You add something to that, and then you square root it. It's going to be bigger than 13.3. So let's see how this works. Okay, that's what we expect, right? It's going to hit the ground faster than 13.3. So let's see, 13.3 squared plus 2 times negative 9.81 times negative 47. You could, of course, make those both positive, but I'm making them negative in a righteous way. Okay, here we go. I've got an answer. 33. We know that the absolute value of the velocity is 33.1516. By the way, I'm going to store that in my variable v. So I don't have to write it down actually with all that much precision. Okay. Now, what that means is that it's either positive, right? That the velocity is actually, it could be positive 33.1516, or it could be negative 33.1516. Okay. I think that when the bagel hits the ground that it's going down. Okay, so the only thing that really makes sense here is this guy. Okay, this has to be the answer. When it hits the ground, the velocity is definitely negative. Okay, So we have to make a little judgment here, right? I don't know what this one means, but this is the correct answer. So normally we just sort of say, oh, let's use the positive, right? Here we choose the negative because when that bagel hits the ground, it's moving down, and negative means down. Okay, so that's what I'm going to choose. Okay, now the question is, how much time does it take to hit the ground? We could use s equals ut plus 1 FAT squared and solve the quadratic. In this case, we would take the positive root. There'd be a negative root and a positive root. But since we've found the final velocity, and since we've used our brain and thought about it and said, oh, I'm going to choose the negative answer because it's striking the ground, it's going down, we deserve to use an easier formula. So I'm going to use V equals U plus AT. My pen is sampling so slowly. That's annoying. Okay. This is a new MacBook Air too. Why would it be slower than my old MacBook? Okay, so it's negative 33.1516. As my final velocity, that's hitting the ground, right, is 13.3 plus negative 9.81. Just slow the pen down and it'll draw. And then that's times t. Okay, so this is like higher mathematics. How could I possibly solve that? Well, I'm going to do it. I'm going to, I guess, subtract this from both sides. Divide that by negative 9.81. I get a time of 4.735. whatever seconds. Okay, I guess with 3 sig figs, we'd say boop. Right, we've got the final velocity negative 33.1. I'd actually say that's a 2. I must have had rounding issues when I made those answers. And then the answer for how high is the helicopter when it hits the ground. Let's figure that out in the next one. Okay, it's not really, I don't do any assessment. I wouldn't put that on an assessment, but it's an interesting question. So let's do that.